In this video, we're going to look at how Jamovi can do inference for a single population mean, both looking at a confidence interval for the population mean and testing for the population mean. I already have a data set loaded in. So first, to do the confidence interval for the population mean, we're going to go to exploration, and then we're actually going to go to descriptives, which we've seen before in earlier stuff in the course. But we can add the extra option to get the confidence interval too. I'm going to look at the variable credits, which is how many credits the student's taking, which is a quantitative variable, so we would work with means. If you go to the statistics option here and look at all the things we can do, I'll get rid of a little bit again here to clean this up. But notice that among all the options here, down under mean dispersion, there is this checkbox for a confidence interval for the mean. If you check that and you look at our table now, we have a 95% confidence interval mean lower bound and an upper bound. So the confidence interval for the mean at the 95% level is 15.126. You can change this to whatever level you want. Maybe we want a 99% interval. We can see it changed, and then the interval did get wider for us. Next, we will look at how we would test for the mean. So let's look at testing if the population mean credits is different from 16. We're going to do that under the t-test option up top here, and this would be a one sample t-test. We're looking at one variable. We put credits as our dependent variable, and then what we want to do is, under the hypothesis option here, change the number we're testing for. So we're going to test if it's different from 16. So we'll put 16 there, and we can see then that's changed down here once I put in a 16. The nice thing is it does note for you underneath the table what your alternative is. So you can see it is an alternative of mu not equal to 16. The test statistic we got is negative 2.23. Degrees of freedom of n minus 1 is 51 minus 1, giving us 50, and that produces a p-value of 0.031. If we wanted to change the direction, if we were doing greater than, we can see we have the same test statistic, but now it's going to look under the t-distribution to the right of negative 2.23, which produces a p-value of 0.985. On the flip side, when we do less, it would flip to the other direction of less than, or to the left of negative 2.23, so you can see then we get that 0.015. And so what the not equal to is doubling what we're seeing here. It has been rounded off a little, but doubling the 0.015 is producing something close to 0.03. So that's how we're able to do that test. If you did want any additional information, you can click descriptives. And if you hadn't already looked at that earlier, up here we can see that some of the statistics for a variable we're testing for, like the mean, the median, and the standard deviation.